Hello everyone, welcome to the series of the USCIS Coding Challenge application video walkthrough. In this channel, we are going to see how Anika Vital Team prepares, designs, and implements a system with application and infrastructure components, and pack the solution to meet the customer's requirement. Today, we are going to focus on initial requirements gathering. We will read the prompt from the customer, understand how it impacts our application design, and come up with a draft system picture. I wish it does not only explain how our team completes the task, but also give you an idea on how to analyze the requirements from your customers and get started with your projects. For this session, I divide the content into 5 pieces. We will look at some specific requirements on front-end and back-end first, then move to the overall system requirements, and finally check some bullet points which also guide us on picking up right technologies for completing the tasks. We will end this session by summarizing the information we learned from the input and get ready to explore the solutions to meet those requirements. Let's get started with front-end business requirements. Those requirements define the way that end users interact with the system, collect the information from users' entry, and pass it to the backend for getting a response. From this screen, we can see the original prompt indicating the criteria that the application's frontend needs to meet. Let's see what kind of key information we can extract from this paragraph. The first bullet point describes the needs of digitalizing the Form G1256. Basically, we are expected to provide an online form that can collect the same fields as paper one does. In order to allow the users to fill in the form, we can choose a web application, a desktop application, or a mobile app. A web application might be the most popular one for this purpose, but at this moment, we cannot confirm it is a target platform yet. We are going to find more supporting information to make sure it is the case later. A paper form looks like this. And the web page we need to build will look like this. Besides, the application must allow the immigration case officer, supervisor, applicant, and the interpreter to securely log in, complete the document, sign the document, and approve the document. It tells us that we need to provide a way to allow users to log in the system. Each user is associated with a role. It can be either immigration case officer, supervisors, applicant, or interpreter. Depending on who they are, they may perform different actions on a document. The third front-end requirement is related to the case assignment. Each case record will be associated with 2 users. The first one is the applicant who completes and submits the form. Once submitted, the case may become read-only to the applicant, but the applicant can still log in the system and track the status change. After submitted, this case will be assigned to a case officer. In any case, only the applicant who submits the case and the case officer who is assigned to this case have the permission to view and work on the case. Therefore, the system can not only use the user role to determine the visibility, but also use the external keys from the case record to identify the allowed users. The only exception is the supervisor, who can view all the cases regardless the assignment. Now we have a good understanding on the scope of the work in the front end. Let's take a look at what we need to do for the back end. Again, let's break down and check the criteria one by one. This application needs to communicate with an external API from USPS to verify the interviewee's name and address. At this moment, we cannot decide if the service call should be sent from the front end or the back end. We need more information to understand the expected behavior if the verification fails to make the decision. The interviewer must have the ability to upload identity document. To implement a function of file uploading, we will need to allow users to select a file from the local machine through a front-end page, post it to the backend endpoint, and save it in a storage. In addition, the application should automatically reject incomplete or erroneous applications for update prior to resubmission. It is common to validate the field form. Again, we have options to perform the validation in the front end or the back end. The front end validation normally occurs right after users switch the cursor or before the form submitted to the back end. Users can immediately be notified for correcting an error or entering the value of a required field, and the system will not keep the invalid form until the validation passes. The backend validation occurs after the form is submitted. It still saves the form data to the database even if it contains errors. The status of this case will indicate it is rejected and get blocked for further processing. Based on the description from the prompt, we select a backend validation in this scenario. The next requirement is regarding the notification. It is also common that the prompt does not clearly state all the details of a function and relies on the development team to make an assumption. Based on the context, we know that the stakeholders of a case include the applicant and the case officer, and they should be listed as the recipients. Since we enforce the user to log in, we may have already saved their email address when registering the account. We can simply find the email address from user's profile. As of now, we have collected the requirements of both front-end and back-end and come up with a draft workflow. We have the UI layer to interact with the users, the microservices to represent the business domains, and some other services to enable the notification, user management, verification, and the storage features. The coding challenge also contains the nice-to-have features. If we have the capacity, completing those optional features will make us outstanding. The requirement we have here is about interview scheduling. As a system designer, we should be aware that a case officer may have multiple cases to handle. If an applicant reserves a time slot to meet with a case officer, other applicants will not be able to pick up the same slot. This conflict check should be considered. In addition to the front-end and back-end requirements, we also have the system requirements to meet. Compared with the business requirements we just went through, the system requirements are more related to the hosting platform, the deployment, and the source code. The solution shall only include open source code, libraries, scripts, and AWS, as well as any open source OWASPs complained to. So we can only choose the open source technology, and the system should be hosted in AWS. Here we can have more specifications on the system. The developed application need to follow the microservice pattern, gets deployed through CI/CD pipeline, and runs as Docker containers. We are also told to create 3 environments, and they should all deployed through CI/CD pipeline. Regarding the source repositories, we want to confirm if our customer prefers a single repository for everything or separate the repository to match individual microservice. Separated repositories usually make it easier to trigger the pipeline and minimize the build scope. Finally, we will check the delivery requirements, and they also contain the important information to design the system. The delivery requirements can also help us to double-check if a previous draft system design in our mind is on the right direction. For example, we can see the first delivery requirement to talk about accessing the application from different browsers. In a previous slide, we figured out that both web application, desktop application, and mobile app might all fit the business and system requirements. However, due to the browser compatible delivery requirement, we're 100% sure that a web application is what we are going to build. We also see the terms of microservice and the CI/CD pipeline are mentioned again. There are some web development solutions such as ASP.NET and PHP, which can provide the presentation layer and backend processing layer through a single endpoint. However, according to the delivery requirement we see on the screen, the frontend and backend have to be separated. Therefore, a lightweight web UI plus a group of backend APIs best fit the need. We also have the flexibility to choose a single or multiple backend services, depending on the domain object we can divide. The last delivery requirement is about the device type we need to support. Due to the difference on the screen size, most web applications do not only zoom in the standard layout on a mobile device, but also rearrange the web controls to avoid horizontal scrolling. When targeting different types of devices, we need to build the script or apply an UI framework to present the same content differently and include the automated testing stage in the pipeline to simulate the popular devices to ensure the compatibility continuously. After analyzing the individual requirement from the prompt, it is time to put the extracted criteria together and come up with a checklist to develop an architecture design. Compared with the original user language, the extracted requirement list does not contain the business details and make it more generic and easier to follow. It also gives us the keyword to search for a common solution. In the next video, I'm going to show you, based on these requirements, how do we select services and design the application modules for the coding challenge. Thanks for watching, and see you in the next video.